Okay, this is a recall question. We are asked which material produces the strongest electromagnet. Okay, strongest electromagnet, we have to choose a soft magnetic material, which is iron, because it is easy to magnetize and easy to demagnetize. Answer C. Okay, in this question, as the current flows through X, Y, because it's in a magnetic field, it will experience an electromagnetic force. So we are asked which change can make the wire XY move up a smaller distance. Moving up a smaller distance means that we want the electromagnetic force to be smaller. Okay, now let's look at the option. Reverse the terminal of the battery will reverse the direction of the current. So this will change the direction of the force instead of the magnitude. So it's wrong. Using a stronger magnet, it will make the electromagnetic force stronger and will move up a bigger distance. It's not right as well. Reversing the poles of the magnet will also reverse the direction of the force only. This is wrong also. And part D, connect the resistor in series with the battery. This will increase the overall resistance of the whole circuit, and as the resistance increases, the current will decrease. And when the current decreases, it will bring about a smaller electromagnetic force, and hence the wire XY will move up a smaller distance. Answer D. Okay, when there are two wires placed side by side and the current are both flowing into the paper, we have a resultant magnetic field that is of this shape, figure of 8, going in this direction. Okay, we can see that the magnetic fields are stronger by the side as compared to the center. So this will cause the wire to move towards the center, and there should be a force of attraction. So in this case, we can see that the answer should be C. Okay, in this question, we have a step-up transformer. So the voltage on the secondary coil will be larger than the voltage in the primary coil. Okay, so now let's look through the option. An alternating current in the primary coil, it gives rise to a voltage in the secondary coil. Yes, this is correct. And option B, the current in the secondary coil is larger than the current in the primary coil. This is wrong, okay, because we know that the power across the primary coil and the secondary coil, it is constant and is equal to VI. So since the voltage on the secondary coil is larger, the current of the secondary coil, it should be smaller than the current in the primary coil. Okay, so option B is wrong. Option C, there is a current from the primary coil to the secondary coil through the core. Okay, what actually flows through the core? It will be the magnetic flux only, not the current. And for option D, transformers are more efficient when using DC current. Okay, this is not right because the transformer will not work if you input a DC current. So the answer is A. Okay, for this question, we need to understand that if we have a long transmission line, that means we have to include the resistance of the transmission line. Okay, so what we can do is just to add in a resistance that is in series. Okay, so when X is being switched off, it becomes like a series circuit of resistance R with the resistance of Y, which looks something like this. Okay, so what is the difference is the change in resistance across this branch. Okay, now let's put in an arbitrary value for the resistance of X and Y. Okay, let's take it that they are both 2 ohm. Okay, if we were to go and calculate the total resistance of this parallel branch, we'll end up with 1 ohm as the total resistance here. And after we have taken out X, we find that Y has a resistance of 2 ohm. So we can see that the resistance across this branch when X is being switched off actually increased from 1 ohm to 2 ohm. And the voltage is being splitted across proportionally between R and Y. And in the previous case, the voltage is being splitted across R, which take V1, and the parallel connection of these two resistors can take V2. And since the resistance of this part increases, now the voltage across Y, it should increase. Okay, so we can write down the voltage across Y, it should increase. So we look at the answer, there is a rise in the voltage supplied. Okay, part C and D are correct. Okay, now let's look at the power. Power is equal to V squared over R. So if the voltage increases and then the resistor of Y, it remains the same, the power should increase as well. So the answer is C.